Right now, at this exact moment, something is moving through our solar system that should not exist. Not in this trajectory, not at this speed, not with these numbers. On October 21st, 2025, a 20-kilometer object traveling at 245,000 kilometers per hour passed behind the Sun in perfect alignment with the ecliptic plane of every major planet in our system. During those hours of solar conjunction, when Earth-based telescopes were physically unable to observe it, the object designated 3I/Atlas executed its closest approach to our star. When professional astronomers talk about this publicly, they use words like comet and natural phenomenon. In private channels, in the observation logs that don't make press releases, they use different words: configuration, maneuver, signal. Let me be clear about what we're dealing with. 3I Atlas was discovered on July 1st, 2025 by the Asteroid Terrestrial Impact Last Alert System in Chile. Within 72 hours, the International Astronomical Union had confirmed its interstellar origin through orbital eccentricity measurements. The number they calculated was 6.2. To understand what that means, you need to know that any orbital eccentricity above 1.0 indicates an object not gravitationally bound to the Sunday. 1I Oumuamua, the first confirmed interstellar visitor in 2017, had an eccentricity of 1.2. 2I Borisov, discovered in 2019, came in at 3.6. 3I Atlas shattered that record by 72%. This object is moving so fast, with such extreme hyperbolic trajectory, that conventional astrophysics struggles to model where it came from or how it achieved this velocity profile. The Pan-STARRS survey, the Very Large Telescope in Chile, the Gemini North and South Observatories, the Hubble Space Telescope, and the James Webb Space Telescope have all been tracking this object. NASA's Jet Propulsion Laboratory's Center for Near-Earth Object Studies has been running continuous trajectory refinements since discovery. The European Space Agency's Space Situational Awareness Program has dedicated resources to round-the-clock monitoring. When this many institutional assets focus on a single target, when observation windows are described in procurement documents as critical national interest, you pay attention to what they're not saying as much as what they are. Think of our solar system as a disk, a relatively flat plane where planets orbit. That ecliptic plane represents the primary traffic pattern of our cosmic neighborhood. Random interstellar objects, debris ejected from other star systems, should arrive from any direction in three-dimensional space. The statistical probability of an object entering our system aligned within 5 degrees of the ecliptic plane is roughly 3%. 3I Atlas came in aligned to within 4.8 degrees. That's the first anomaly. The object's trajectory brings it within 0.65 astronomical units of Venus, 0.19 astronomical units of Mars, and 0.36 astronomical units of Jupiter. 1 astronomical unit is the Earth-Sun distance, roughly 150 million kilometers. For context, missions to Mars require years of planning to achieve similar approach distances. 3I Atlas will pass all 3 planets in sequence during October and November of 2025, without any mid-course correction burns, without any observable thrust signatures. Natural objects don't optimize trajectories. Here's what makes professional astronomers nervous. During the prediscovery analysis, the Zwicky Transient Facility went back through archived data and found 3I Atlas as far out as 17 astronomical units, approximately a year before official discovery. The object was already active then, showing a coma of gas and dust at a heliocentric distance where most comets remain dormant. The brightness profile showed a steepening rate proportional to the inverse cube of distance, specifically inverse 3.8 power. That brightening curve is not consistent with primordial interstellar comets like 2I Borisov. It matches the behavior of dynamically old comets, objects that have been thermally processed, that have been near stars before, that have undergone multiple heating cycles. Let that sink in. An object arrives from interstellar space, supposedly wandering the void for millions or billions of years, and it behaves like something that has recent stellar encounter experience. The Smithsonian Astrophysical Observatory and the Catholic University of America analyzed the spectroscopic data from the Very Large Telescope and James Webb. They found the highest carbon dioxide to water ratio ever measured in any cometary coma. The CO2 abundance is off the scale compared to solar system comets. They also detected nickel in concentrations that don't match any known natural formation environment. The working hypothesis published in August 2025 suggests 3I Atlas may have traveled for 7 billion years or more through the galactic disk, passing through interstellar clouds, through star-forming regions, through supernova remnants, accumulating what they're calling a cooked shell on its surface. 7 billion years is longer than Earth has existed as a planet. The statistical improbability of such an object arriving in our system during the brief window of human technological civilization capable of detecting it is not lost on the researchers writing these papers. The Southwest Research Institute, under the direction of the principal investigator for the New Horizons mission, released a detailed mission study in February 2024 before 3I Atlas was discovered, proposing an interstellar object explorer capable of reaching velocities necessary to intercept future visitors. That study explicitly mentioned observation windows, optimal launch trajectories, and the critical importance of early detection. In October 2025, researchers published trajectory optimization showing that a spacecraft launched in July 2024, one full year before 3I Atlas was discovered, could have intercepted the object using gravity assist from Jupiter. The delta V requirements, the velocity changes needed for intercept, are detailed in the published orbital mechanics. Someone calculated this trajectory backward from observation data. That someone knew the math before the rest of us knew the object existed. Here's the terrifying part. From July through October 2025, as 3I Atlas crossed the orbital paths of the outer planets and entered the inner system, multiple observation teams reported what they carefully termed a sunward jet. Not the typical dust tail blown away from the sun by solar radiation pressure, a jet pointing toward the Sunday, an anti-tail. The European Southern Observatory confirmed this is not a geometric perspective illusion. Real comets don't show sustained anti-tails, except under very specific viewing angles that weren't present during these observations. In astronautics, there's a principle called the Oberth effect. If you want to change a spacecraft's velocity most efficiently, you burn your engines at perihelion, at closest approach to the star, when your orbital velocity is highest. The impulse you apply when moving fastest produces the maximum change in kinetic energy. It's basic orbital mechanics, taught in every aerospace engineering program. Professional spacecraft missions use Oberth maneuvers routinely because the physics are settled science. 3I Atlas reached perihelion on October 29, 2025, at 11:44 Universal Time, at a distance of 1.356 astronomical units from the Sunday. For approximately 48 hours before and after that moment, the object was in solar conjunction, positioned directly behind the Sun as viewed from Earth. No ground-based telescope could observe it. Space telescopes capable of solar observation, like the Solar and Heliospheric Observatory, were not configured to track objects at that distance and velocity. The observational blackout was total. When 3I Atlas emerged from behind the Sun in early November, if its velocity profile has changed, if its trajectory has altered even slightly, we'll know. Or rather, we'll calculate, we'll model, we'll run the numbers and compare them to the preconjunction predictions. And if the math doesn't close, if there is a velocity residual that can't be explained by solar radiation pressure or outgassing or any of the natural forces we understand, then we'll have the conversation that institutional science has been avoiding since July. Let me walk you through 3 scenarios that fit the observational data. None of them are comfortable. Scenario 1, the benign interpretation. 3I Atlas is a natural comet from an ancient population of interstellar objects. Its unusual chemistry reflects formation conditions in a stellar environment very different from our Sunday. The high CO2 ratio, the nickel detection, the steep brightening curve, the ecliptic plane alignment, the close planetary approaches, the sunward jet, the solar conjunction timing, all of these are remarkable coincidences, but ultimately explicable through exotic natural processes we haven't yet fully characterized. In this scenario, we're simply witnessing a data point from a sample size of 3. With only Oumuamua, Borisov, and Atlas to study, we don't yet know what normal looks like for interstellar visitors. The Verisi-Rubin Observatory, scheduled to begin its legacy survey of space and time in January 2025, is expected to detect between 15 and 70 interstellar objects per year when we have that larger sample. When we've cataloged hundreds of these objects, the current anomalies will resolve into a broader understanding of natural variation. This interpretation requires accepting that human civilization happened to develop observational capability at precisely the moment when an exceptionally rare 7-billion-year-old comet arrived in our system after wandering the galaxy since before Earth's formation. Scenario 2, the warning interpretation. 3I Atlas is natural, but represents a category of object that poses systematic risk. The research published by Harvard's Astronomy Department and Cornell University calculates that the interstellar object population in our galaxy is orders of magnitude larger than previously estimated. If 3I Atlas's 20-kilometer diameter represents a typical size distribution, and if such objects regularly pass through stellar systems undetected, then impact hazard assessment needs fundamental revision. The trajectory optimization studies showing how close 3I Atlas passes to multiple planets aren't academic exercises. They're proof of concept for real threats. A 20-kilometer impactor traveling at 245,000 kilometers per hour carries kinetic energy measured in millions of megatons. The dinosaur-killing Chicxulub impact 66 million years ago involved an object roughly 10 to 15 kilometers across. 3I Atlas is larger, faster, and came from outside our system, which means detection and deflection timelines are compressed. In this scenario, the intense observational focus, the institutional coordination, the silence around certain details, all of this reflects a scientific community grappling with a threat assessment that hasn't been made public because the mitigation options are limited. You don't announce that Earth-crossing interstellar objects are common until you have credible plans for dealing with them. Scenario 3, the diagnostic interpretation. 3. IATLAS is neither random nor threatening. It's a survey, a probe, a test payload sent to measure our detection capabilities, our response time, our level of technological sophistication. In this model, which I want to be very clear, is ranked as highly improbable by most astronomers, but cannot be definitively excluded by the data, the object's anomalies are features rather than bugs. The ecliptic plane alignment ensures close approaches to inhabited worlds. The timing of solar conjunction provides a predictable observation blackout for potential maneuvers. The sunward jet might be attitude control rather than outgassing. The absence of a visible comet tail, despite measured acceleration, fits a low albedo artificial surface better than it fits a volatile, rich comet nucleus. The 7 billion year transit time dissolves if the object didn't originate 7 billion years ago, but was manufactured in interstellar space within the past 1,000 or million years, using resources already present in the galactic disk. Under this interpretation, 3i Atlas is doing exactly what Voyager 1 and Voyager 2 are doing right now as they exit our system toward interstellar space, except in reverse and with better propulsion. Before you dismiss Scenario 3 as fringe speculation, consider the improbability stack. Each individual anomaly has a natural explanation that requires some statistical luck or unusual circumstances. The ecliptic alignment is unlikely but possible. The planetary approach geometry is remarkable but not impossible. The sunward jet is strange but potentially explicable through asymmetric outgassing. The timing of solar conjunction at perihelion is convenient but not unprecedented. The chemistry is exotic, but maybe that's just how old interstellar comets work. The problem is when you multiply these independent, low-probability events together. When you stack 6 or 7 or 8 anomalies that each require their own special pleading, the cumulative improbability starts to exceed the improbability of alternative hypotheses. This is how detection works in the search for technosignatures. You don't look for a single smoking gun. You look for clusters of anomalies that resist conventional explanation. The most famous example is the WOW signal detected by the Big Ear radio telescope in 1977, a 72-second narrowband radio burst that matched no known natural source and was never repeated. For 48 years, that signal has remained unexplained, neither confirmed nor debunked. 3i Atlas is visible, trackable, studied by multiple independent observatories using different instruments. The data is public. The trajectories are confirmed. The chemistry is published in peer-reviewed journals. This is not ambiguous radio data from a single detection. This is an object that is here, now, moving through our system, with parameters that professionals find disturbing enough to write papers proposing spacecraft intercept missions. The observation timeline through the end of 2025 and into 2026 is critical. Here's what to watch for. First, precise trajectory measurement post-solar conjunction. By mid-November, the orbital refinements from Hubble, James Webb, and ground-based observatories should resolve whether 3i Atlas experienced any velocity change during the October blackout. If the post-conjunction orbit matches the pre-conjunction predictions within measurement error, that supports natural explanations. If there's a residual acceleration or trajectory adjustment beyond what outgassing can explain, that's problematic. Second, the Mars close approach on October 26th at 0.19 astronomical units. NASA's Mars orbiters, including the Mars Reconnaissance Orbiter and the MAVEN atmospheric probe, have imaging capability. The Perseverance and Curiosity rovers on the surface could theoretically image 3I Atlas if lighting conditions permit. Any change in the object's brightness, any deployment of structures, any unexpected behavior during the Mars flyby would be documented by assets already in position. Third, the Venus approach in late November at 0.65 astronomical units. The Parker Solar Probe, which conducts close solar passes, may capture data during its own orbital path. The European Space Agency's solar orbiter might have observational windows. Venus is atmosphere shrouded, but its orbital zone is well monitored. Fourth, the behavior as 3I Atlas exits the inner system in December and January. Does the outgassing pattern continue? Does the sunward jet persist or disappear? Does the object maintain its hyperbolic trajectory or show any deviation that suggests course correction? The Vera C. Rubin Observatory in Chile officially began operations in late 2025. Its 8.4-meter Simony survey telescope can image the entire visible southern sky every few nights with unprecedented sensitivity. 3I Atlas will be in prime observational position for Rubin through the first quarter of 2026. Fifth, and this is where things get interesting, watch for pattern repetition. If 3I Atlas is truly a scout or probe, the logical follow-up is either return trajectory adjustment or arrival of additional objects. Statistical models suggest that if interstellar visitors are common, we should detect multiple objects per year once Rubin reaches full operational capacity. If we suddenly start seeing more objects with similar anomaly profiles, that's signal. If we see nothing else like 3I Atlas for the next decade, that's also signal. Both outcomes tell us something. Silence after an anomalous event is as informative as noise. The institutional response to 3I Atlas has been measured, procedural, and notably devoid of speculation. NASA press releases describe it as an interstellar comet and emphasize its scientific value for understanding planetary formation in other star systems. The European Space Agency publications focus on observational techniques and future mission concepts like the Comet Interceptor program scheduled for launch in 2029. Academic papers published through September and October 2025 carefully hedge their language, using terms like unusual, unexpected, not typical, and requires further study. Nobody is using the word artificial. Nobody is publicly discussing threat scenarios. Nobody is making the connection to the broader implications of first contact or near-miss impact hazards, or any of the existential questions that naturally arise from a 20-kilometer object of unknown origin executing a precision tour of our inner solar system. That silence is a data point. When astronomers discovered Oumuamua in 2017, the speculation was immediate and widespread. The cigar shape, the tumbling motion, the acceleration profile, all of this generated serious academic discussion of technological origins. When that discussion became public, it was criticized as premature, as sensationalist, as lacking sufficient evidence. The lesson was learned. This time, the professional community is keeping the speculation internal until the observation program completes. But the observation program for 3I Atlas includes mission proposals for spacecraft intercept. The Southwest Research Institute published detailed engineering studies showing how to catch these objects. Project Lyra, an initiative by the Institute for Interstellar Studies, has been refining intercept trajectories since Oumuamua. These aren't thought experiments. These are mission architectures with delta-V budgets, launch windows, and payload specifications. If scenario 3 is correct, if 3I Atlas represents intentional observation by non-human intelligence, then the object has already collected the data it came for. Our detection methods, our response time from discovery to institutional mobilization, our telescope network coverage, our spectroscopic analysis capability, our orbital mechanics expertise, all of this has been measured. The object has passed through our system with minimal interaction, executed its perihelion maneuver during an observation blackout, and will exit toward interstellar space, carrying information about human civilization's current technological state. From an intelligence gathering perspective, it's elegant, non-threatening, purely passive observation with built-in ambiguity that allows the target civilization to rationalize the encounter as natural phenomena. If you wanted to study a developing species without triggering first contact protocols or existential panic, this is how you do it. But here's the critical point. This line of reasoning, while internally consistent and supported by the cumulative weight of anomalies, remains speculative. It is not the consensus position. It is not what most astronomers believe is happening. The mainstream interpretation is scenario 1, natural but unusual comet. A substantial minority takes scenario 2 seriously, viewing 3I Atlas as evidence that interstellar impact hazards need better characterization. Scenario 3 is discussed in published papers by respected institutions, but always with heavy caveats and acknowledgement that natural explanations are more probable. Science operates on evidence, not on cascading chains of inference. And the evidence, while strange, is not yet conclusive. The Vericy-Rubin Observatory changes the game. Starting in early 2025 and ramping up through 2026, Rubin will conduct the most comprehensive sky survey in history. The Legacy Survey of Space and Time will image billions of objects, detect thousands of near-Earth asteroids, and almost certainly find dozens of interstellar visitors. If 3I Atlas is genuinely unique, if we don't see others like it, then the anomaly stack becomes harder to explain away. If we see a whole population of similar objects, the natural explanation gains strength. Either way, the next 18 months provide an observation baseline that has never existed before in human history. We are living through a transition point. For hundreds of thousands of years, humans looked at the sky and wondered if we were alone. For the past century, we've had the technology to detect radio signals from other civilizations. For the past decade, we've been able to characterize exoplanets and identify potentially habitable worlds. And now, for the first time, we're tracking objects from other star systems as they pass through our cosmic neighborhood. The question of whether we're alone is becoming an observational science rather than a philosophical debate. 3I Atlas is either a comet, a hazard, or a visitor. Those three categories have very different implications, and we don't yet know which column it belongs in. Stay with this timeline through November, December, January. Subscribe to follow the observation reports as they emerge. The post-conjunction trajectory data should be published by mid-November. The chemistry analysis from James Webb will continue through December. The exit trajectory refinements extend into early 2026. And the Rubin survey begins delivering data that will contextualize 3I Atlas within the broader population of interstellar objects. This is not a story that resolves with one dramatic announcement. It's a story that unfolds across observation windows and peer review cycles and incremental data releases. Science moves at the speed of verification, not at the speed of headlines. But ask yourself this: If you were an advanced civilization wanting to assess whether a developing species had reached technological maturity, how would you test them? Would you make contact directly, risking cultural contamination or hostile response? Would you broadcast radio signals that might be detected by a species that hasn't developed interstellar travel yet? Or would you send something physical, something detectable but ambiguous, something that could be rationalized as natural by a civilization not ready to accept the implications, but would be recognized as artificial by a civilization sophisticated enough to notice the pattern? The pattern is there. The ecliptic alignment, the planetary approach sequence, the solar conjunction timing, the chemistry that doesn't match solar system templates, the sunward jet pointing the wrong direction, the brightness profile suggesting thermal history inconsistent with primordial interstellar wandering, the observation blackout at perihelion, the 20-kilometer diameter, making it the largest interstellar object ever detected, despite being the third one found, which statistically should mean we're seeing the rare giants first before the common smaller ones, except that implies there are thousands of smaller objects we haven't detected yet passing through our system unobserved. Comment below with your assessment. Is this contact wearing the mask of coincidence? Or is this exactly what pattern-seeking primates do when confronted with ambiguous data, finding meaning in noise, because we're evolutionarily wired to detect agency even when none exists? Both interpretations fit the data we have right now. Both are consistent with the observations from Pan-STARRS, Hubble, James Webb, the Very Large Telescope, Gemini, the orbital mechanics from JPL. The math works for natural comet. The math also works for survey probe. The difference is not in the numbers. It's in the framework you choose to interpret the numbers. 3. Atlas will pass Jupiter's orbital radius in late November 2025. It will cross Saturn's orbit in April 2026. By late 2026, it will be beyond Uranus. In 2028, it passes Neptune's orbit. In 2038, it reaches the heliopause, the boundary where solar wind gives way to interstellar medium. And then it's gone, headed toward whatever part of the galaxy it came from, carrying whatever data it collected, leaving us with observation logs and spectroscopic measurements and trajectory plots, and the unresolved question of whether we just watched a comet or witnessed first contact. We won't know with certainty. Not from this one object, but the observation infrastructure we've built to study 3I Atlas will be ready when the next one arrives, and the next one after that, and the one after that. The detection rate is about to increase by 2 orders of magnitude. Within 5 years, we'll have enough data points to identify genuine patterns or conclusively rule them out. The question of whether we're alone will have a statistical answer rather than a philosophical one. We're in the last moment where speculation is the only tool we have. That moment is ending. The data is coming. Watch what happens next. Are we alone? That's not a rhetorical question anymore. It's an observational program with scheduled observation windows and funded telescope time and peer-reviewed analysis pipelines. 3I Atlas is the third data point. The Rubin Observatory will provide data points 4 through 70 over the next decade. We're building a sample size large enough to answer the question empirically, but sample size doesn't matter if you're not asking the right questions. And right now, the professional astronomy community is very carefully not asking certain questions in public, while simultaneously publishing mission proposals for spacecraft intercept of future interstellar objects and refining protocols for techno-signature detection, and conducting workshops on the societal implications of confirmed non-human intelligence. The gap between what's being said and what's being prepared is a data point. The institutional response to 3I Atlas has been comprehensive, coordinated, and procedurally cautious in a way that suggests the stakes are understood even if they're not being articulated. When NASA dedicates Hubble and James Webb observing time, when the European Southern Observatory reprioritizes the Very Large Telescope schedule, when multiple national space agencies coordinate tracking of a single object, that's not routine scientific curiosity. That's protocol activation. And protocols exist for scenarios someone has already thought through. So here's what we know with certainty. An object 20 kilometers across arrived from interstellar space in July 2025, traveling faster than any natural object ever observed in the solar system. It aligned itself within the ecliptic plane to within 5 degrees. It executed close approaches to Mars, Venus, and Jupiter in sequence. It displayed a sunward jet inconsistent with normal cometary behavior. It showed chemistry suggesting billions of years of interstellar travel through environments that should have eroded volatile ices. It passed behind the sun at perihelion during a 48-hour observation blackout. It has been tracked by every major observatory on and off Earth. And it will exit our system in 2026, carrying whatever answers it came here to find. Everything else is interpretation. And interpretation depends on whether you believe the universe is indifferent or paying attention. Stay on the timeline as this unfolds. Because regardless of which scenario is correct, regardless of whether 3I Atlas is comet, hazard, or probe, we are now living in an era where interstellar visitors are detectable, trackable, and subject to scientific investigation. The question is not whether they're coming, they're already here. The question is what they are and what they want, and whether we're capable of recognizing the answer when it's staring us in the face from inside our own orbital mechanics data. The solar conjunction has passed. The observation blackout is over. The post-perihelion measurements are being compiled right now, today, as you hear these words. By the time this timeline reaches mid-November, we'll know if 3I Atlas changed velocity. We'll know if the trajectory math closes or if there is a residual that demands explanation. And we'll know whether the institutional silence breaks or whether the careful language continues, and whether scenario 1, 2, or 3 moves from hypothesis to accepted framework. Watch the numbers. Trust the data. Question the silence. And remember that the universe has already shown us it sends objects between stars. Whether those objects are debris or deliberate is a question that science is now equipped to answer. Not through speculation, through observation, through measurement, through the accumulation of data points until the pattern becomes undeniable or the anomalies resolve into coincidence. We're in the transition. We're in the window where the answer is emerging but not yet clear. This is the moment. This is the timeline. And 3I Atlas is still out there, moving away from the sun at 245,000 kilometers per hour, carrying the data it came for, leaving us with the observation logs and the math, and the question that defines our species. Are we alone? Ask again in 6 months. Ask again when Rubin delivers its first-year data. Ask again when the interstellar object catalog reaches triple digits, and we can actually do population statistics instead of extrapolating from 3 anomalous examples. But don't ask rhetorically. Ask empirically, because for the first time in history, we might actually get an answer.